Oh, there you can start the video. Okay.
Yes, we will share the second screen again. So now you can see the screen and we will show image. So now you can see us there. Let us increase the size of this thing. Like that. Okay.
Okay. Hello, welcome to our webinar. Before we start, can I ask the people that represent companies if you can please add the name of the company next to your username in the platform so that we can have some list of the participating company representatives. Okay, so today we are going to speak about the content of our DIGI-MODE project, and we will introduce the digital twin concept and present the user cases and the prototypes that we have been doing for the couple of last months, and hopefully we will have time for some questions and answers. So the purpose of the DIGI-MODE project is to promote the usage of digital tools and in particular virtual and augmented reality solutions for the companies. The project is financed by the European Regional Development Fund, and this project is a collaboration between the University of Vasa, Vasa Technical University, Novia University of Applied Science, and ABO Academy. We have three labs that have been collaborating over the time. In Technobotnia, University of Vasa have the virtual factory, which is dealing with 3D scanning, 3D printing, virtual and augmented reality for industrial manufacturing solutions. And from Vasa Applied Science University, we have a representative from MOVA laboratory.
Right. Hello, everyone. I'm Kimi Wenström, designer at Design Center MOVA. We are here with my colleague, João Pereira, to present what MOVA is working in DIGI-MODE project. Our project manager, Jari Ratilainen, is occupied at the moment and will be joining us later. MOVA is the design department of Vasa University of Applied Sciences that engages in R&D activities and offers product and service design to companies in the region. Yeah, welcome all.
Thank you. Thank you. And okay, my colleague Dennis will present Novia.
Yes. Hey, I'm Dennis Bengtsson. I am one of the project workers here at Novia. I am working mostly with the software implementation and 3D scanning aspects of the development process here. Hello.
Okay, thank you, Dennis. And then Joachim from ABO Academy at Experience Lab.
Hello, everyone. I'm Joachim Majors. I represent ABO Academy and Experience Lab. We are a research and development unit at the Faculty of Education and Welfare. So we focus on human-centered design and human-computer interaction. Welcome all.
Thank you. So my name is Raiko Toshev, and I am actually a project manager and lecturer in University of Vasa. And as I said, I am the lab manager for the additive manufacturing and virtual factory laboratory. So the three major digital twins that will be developed in with cooperation with the local companies during this project are focusing on the architecture and construction. The second one is on the manufacturing industry implementation, and then we have together with Vevik laboratory, our engine lab, the digital twin developed for the energy sector. So digital twins, virtual and augmented reality technologies provide value across the whole enterprise. And you can see here it's starting with the design and the actual manufacturing processes, but also sales and marketing can benefit from it, service, training, and also operation and logistics functionalities can be represented, starting with a review of different designs and collaborative design capabilities to something like advanced help desk or job-specific training and remote expert instructions and operations. This is how our digital manufacturing labs look like. So we have ERP, MES system integration together with the 3D representation of the layout and online monitoring of the machine status, tooling, etc. So this is another representation of previous work we have done for the manufacturing simulation and layout preview that offers the possibility to test and optimize the different configuration of the equipment, compare and calculate production key performance indicators, input and output on the factory door, as well as idling and etc. processes. One of the most usual implementation is to compare automation versus manual production. But okay, let's take a step back and describe what a digital twin actually means. So many people are confusing it with the 3D modeling, which is a static model, but a digital twin adds on top of this the data. So in the perfect case scenario, you will have a continuous data flow between the reality and the virtual model, and this will be updated in, as I said, real time. So the collection of the visualization of sensors and data make the real digital twin implementation possible. So here is a reality virtuality continuum graphic representation. On the left side we have the real environment, the real world, and on the right side we have a totally immersive digital environment with no feedback from the real world. And in between we have what is now known as extended reality or mixed reality. So when we have digital models overlapped on the see-through view, we talk about augmented reality, or if we have, for example, video stream on top of the virtual environment showing camera from what is your surrounding, then we talk about augmented virtuality. Here are some of the popular devices in the near past and in the current, what have been used, like a see-through binocular in the case of HoloLens 2, and virtual reality glasses, immersive virtual reality handheld devices, and tracking base stations, HTC Vive and Oculus being the most famous brands. All the contents can be also viewed on a regular desktop, laptop computer, on a tablet or a mobile phone also. Also, there are the most popular software platforms, game engines to create content that can be used for the purpose of content creation. Yeah. Everything starts with creating as much realistic model as possible that can be put in the digital environment. So the help of this purpose comes 3D scanning, and my colleague Taranat will go through some of the process specifics.
Hello, myself Taranat. We'll be discussing about 3D scanning and their purposes. So what is 3D scanning? 3D scanning is a method where you use machines or techniques to create 3D representational data in a digital model. It can be of a human, it can be of a environment, it can be of an object. So they currently the majorly used in the industries for representing real or real places or objects in the digital twins, to make digital copies of humans, and sometimes it's also used in quality control, where the manufactured product is compared to the digital twin and check what is the variations. It's also used for styling and customization, and as well as retrofitting. So we'll talk about three major techniques of 3D scanning. Next is, yes. Okay, the first one is photogrammetry. Photogrammetry is a technique where we capture photos of an object from every direction, and then we use photogrammetry software to process it and create 3D model. Here you have typical placements of cameras while capturing the image of the object, and then you have a video showing how it is represented in the photogrammetry software. So the areas which you need to be careful about is lighting of the photo and depth of field, as well as shutter speed and ISOs. The next technique is called as lidar scanning, where laser beam is projected, and the time taken for the laser beam to come back is calculated, and a 3D point cloud is generated. We have one video as well as images showing of how our metal printing lab is being scanned. Then we have something called as structured light scanning. In this technique, it's quite similar to lidar, but here cameras are used to see see how the light bends, and based on that we create a triangulated data, and then that is converted into triangular mesh using the softwares. So these data are further used and processed to be made as 3D assets in the digital twins technique. My colleague will take the webinar ahead and explain how these 3D models are used. Thank you.
Okay, and then let's move on taking on with this service design.
All right, thank you. So in DIGI-MODE project, Muova focuses on producing a digital twin of an industrial service. For DIGI-MODE, Muova studies energy sector as the industry and logistics as the service by using Cooper Lab environment as platform for the development of the digital twin. And in order to create a digital twin of a service, the service design methods are critical to consider. What is service design? It is researching, arranging and planning service moments in order to create a user-friendly service that is as efficient as possible. Service is an outcome of multiple interacting service paths or chains, and each of these chains contain multiple service moments that have their unique interactions between users and provider. For example, when the customer is getting the package they ordered is one service moment that has its own interactions. The Cooper Lab environment that we are going to use to create this digital twin is based on these service moments that I described. The Cooper Lab environment is a fast service prototyping platform to create and experience rapidly created services in virtual reality. the efficiency of CoProLab is based on pre-made libraries that are 3D libraries. And they contain objects, NPCs, different kind of emotions and interactions. And this enables the user to create unique service moments from scratch.
Thank you, Kimi. So how can we use CoProLab? We present here a framework how this tool can be used together with companies. And it starts with a meeting with a company that where establish the goals of the digital twin, the metrics to evaluate this digital tool as well, and also write down the entire journey of the service, of the industrial service with the company. With the use of CoProLab virtual environment tools, it will be possible to prototype in virtual reality and obtain the digital twin. And with this digital twin, we enter in a very wide options that we can test different scenarios to see how the service can be improved, and even though create or evaluate them in a different ways. At the same time, this digital twin can be used for 3D visualization and used in a comprehensive tool for marketing purposes. So this is how you can use CoProLab, and we have here a case that we can go through. And we started with a meeting with a company that focus on logistics services, and we established that we wanted to reduce the number of human interactions between customer and company. And also we defined some metrics to evaluate how this potential service could be. And on the bottom, we have here an image or a scheme that represents the different service moments along the service journey of this company. And with all this information, we were able to rapid prototyping in virtual reality with CoProLab and obtain the experience that we can see in the next video, where we have or where we can see different we can feel the experience of having a digital twin of industrial service. So we have here an overview of the different service moments that goes from the customer order or request to the product to deliver the final step. And we will jump individually in each service moment, starting by the customer order, and where we have here inside the room the customer, and you can have different perspectives how this can happen, and also we can jump in virtual reality to check and have a full immersion experience of all details that the company might request in this specific order, for example. And then we can jump to the company, to the logistics company, to understand how do they handle this order and how do they communicate inside departments. So it comes from the request to transmit this information to the planning and strategy planning for the route and transportation, and communicate this information to the driver. So the driver can prepare the truck with the necessary requirements and, for example, clean it and keep it ready for the load of the materials that happens in the warehouse. So the logistics company keeps all materials from customer. That's part of their service. So they keep in the warehouse all the materials that the customer needs. So they just call and request these materials. And we have here the filling process. So all of this can be visualized in virtual reality. But in this service, they don't have a communication tool between the customer and the company. So basically they use phone calls to interact between each other. So we have here another service moment of the customer requesting information about when is my order arriving. And the driver will answer with all the details. And after answering this and doing the transportation necessary, and when it's close to the factory, the driver will call the customer asking, hey, I'm close, can I unload now in your factory? And we'll receive a confirmation from the customer, and it will proceed to the unload of the cargo in the factory. So this is a potential digital twin of how a service could go here. And the benefits of having this digital twin is that new ways or new potential improvements can be tested here. Like if we have the digital twin, we can go throughout and evaluate all the service moments that we have currently, and then jump to simulate improved versions of this same service. In this case, for example, by implementing an automated communication system between the driver and the customer, so the customer will have real-time information about truck location, and at the same time, estimated arrival time. So this reduces or potentially reduces any kind of information problems or information flows that can happen between the different players, and at the same time improve the quality of the service itself. And all of this can bring several benefits of using digital twins in industrial services, such as, for example, just demonstrates in a 3D way how does the service work, so bringing value to the company by demonstrating for marketing purposes, but at the same time using it to simulate new ways of providing the same service. And this may reduce costs and time for both company and customers, visualize bottlenecks to improve or constraints any problems that may happen or are happening at the moment, and of course improve efficiency of the service.
Yes, thank you for that. Next up, we'll have a short introduction into digital twins in manufacturing from Anastasia Krishnan.
Hello, so next case is the digital twins in manufacturing. Those can be, for example, the factory layout or the manufacturing process created by different kind of software. One of such software is the Siemens NX. Siemens is supporting the product development starting from the concept, design, engineering to the manufacturing by the creating 3D models of the parts, assemblies, and drawings. This is resulting in the integrated system enabling creation of the layout, checking the ergonomics of the machines, and the coordination and streamlining of the entire process. Another kind of software is the visual components. It rather uses the e-catalog or the libraries for the creation of this 3D simulation with a real-time return of the statistical data, visualization or clarifying possible flaws caused by the new machines integrated into the layout. With the created layout, it is possible to have the VR interaction that is shown on the video. The customer can see one-to-one scale production layout and see the data.
Yes, thank you. Yes, and next up we will go to this digital twin for architects. And for that I introduce Joachim Meyers.
Hello everyone, I'm Joachim Meyers. I will be talking about our use case, digital twin for architects. So our way of working, we have to define the problem first. So we've been talking to architects company and just to figure out, okay, what do they need? How can digital twin help them in their process? And together we figured out, okay, what the problem is and what is the solution. Well, the problem that architects usually have is they have to make big changes late in their design process, meaning a lot of time goes to making small changes, mailing each other, the constructor or the city officials or the potential customers wants to make changes to the design, and the architect makes the changes, and it's quite time consuming. Next one, please. So what they actually need is a way to visualize buildings in the real environment, early prototyping, which means basically when you have a map of Vaasa city center and you want to build buildings in the Kasarmi area, for example. So you can take 3D pictures of that area, and then to easily build concepts. Okay, how large would the building be? How broad, and to see how would that building fit into the environment. That's what they need, and to make easy changes collaboratively with the customer. So they don't have to mail each other or book meetings to actually, okay, we want to move that building, it's too high, it blocks the view of the buildings behind them and so forth. So they need something to make easy concept designs. The solution, what we came up with, Experience Lab, Novia, and the architects company, is a concept planning application tool where they can easily take or build buildings or measure buildings, mass buildings in a specific area. This tool would be cross-platform, meaning it could be used on web, VR, AR technology, as well as phones, because it's really important to actually be able to collaboratively build these buildings and make changes to them. Okay, how would the roof be? How tall of a building, and so forth. This is the prototype we are building on. We are actually building it together with the company, with the architectural company. So we will have a prototype, we will test it, and we will make changes, like small iterations and sprints. Thank you. That was our case of a digital twin and architectural twin.
Yes, thank you, Joachim. Okay, so next up we have another well, not digital twin as much as a VR training application, and I think Raiko can speak more about that.
Yes, Dennis, thanks. So for the construction activities and training in virtual environment, we have prepared a short case where we have been implementing different tasks. So currently drilling is possible, and spray painting, scissor lift usage, and these are some of the job-specific tasks that were highlighted during the discussion with the construction companies. We are looking forward also to implement the next steps, electrical installations, and make it well, use the actual buildings that we have been created for the architect demo case. So you can see from first person view the different tools, leveling, meters, hammers, etc. Drills and spray painting, so actually to operate the scissor lift, and when you are painting facades and high level buildings, you need to go through the manual. You need to be instructed in a proper way and licensed to this job. So this environment will be used for both training and hopefully to assist in the licensing, much like you have simulators for airplanes, for pilots, and for helicopters. You can have the similar scenario for operation of this machinery, tools, etc. So you can see the usage of power tools, drill bits, can follow up process, and also now the spray painting with a customizer for the different colors, so you can increase the actual size of the applied paint, etc. Many of the applications in virtual reality involve exactly this: job simulators, training tools for either complex machineries, even in medical, etc. Some physiotherapists are using already these tools. Especially useful it's for building future factories and training on a job spot when you still are planning on the design. So this is allows to synchronize and shorten the training process. Okay. Okay, and Dennis will show you another customizer.
Yeah, the final prototype we have made is an early program we made in the beginning of the project to showcase the possibilities of using VR in design. And this demo we created is basically the same as this massive software before, except in this case you are walking around inside of a house and can customize different aspects of it. It's based upon WebXR technology, so it works in the web browser, on desktop PCs, on virtual reality, on smartphones, and pretty much every platform available. We have a video here of the customizer in action. Let's see. So this is the house customizer prototype. Here you can see when I'm walking around in VR using the Oculus Quest, and you can see these different customizer settings in the center of the screen. This is a really quick and dirty prototype to just show what you can do with VR. Changing different floor panelings, different tapestries. Just going around and seeing how it will look inside of an immersive environment. And yeah, this is working on a web platform, so this right now is opened inside of the Oculus Quest on a regular website, allowing pretty much anyone to just open up and preview the house. Yes. And finally then, we have a short section on digital avatars inside of digital twins. Avatars are 3D or 2D graphical illustrations of users inside of virtual environments. They are commonly found in games, but they're also commonly used in digital twins. The uses of digital avatars are things like human-machine interactions, industrial tasks and job training. You could use human avatars to show you how to do something inside of a virtual environment, for example. You could use avatars for digital collaboration and communication, which I'm sure you've seen in a lot of communication software, where you can see 3D avatars of the users you're talking to. They can be used for tutorials, for visual aids, and remote instructions. They can be used for ergonomic planning, and they can be used for time practice and for virtual mirroring and ghosting. That's again just basically you can use, for example, digital avatars to overlay different tasks you should do in a virtual environment or in an augmented reality environment. Digital avatars can be created in a few different ways. They can be bought using pre-made models. They can be procedurally generated using tools such as MakeHuman or MetaHuman Creator, or they can be scans of real humans, as we saw before, as Tarnat showcased the 3D scanning. And yeah, the last thing we will show is just a short demonstration of creating a 3D avatar using the program MakeHuman. This is a program that creates parametric human models using a kind of morphologic engine, which allows you to really customize a human model, a human to look like anything. So it gives you a lot of possibilities. Yes, and then yeah, you have a lot of different options to to create different clothes, and you can select different pre-made skeletal rigs which are used for animations when you export the model. And then when it comes to animating it, you have also a few different options. You can animate a model using software such as Blender. It's a manual process, but it's perfectly viable. It takes a short while, and you just have to manually move every bone, but it is something that can be done. Another option for animating models is using pre-made animation repositories such as Adobe's Mixamo, which has a huge collection of pre-made animations which you can apply to a pre-made model. Here I'm loading in the same model again, and yeah, I didn't have to do anything special here. It managed to set up a animation rig for the model by itself, just based upon the generic shape of a human. So here you can see the animations being applied to the model, just selecting the animation and having it play out. While this repository has a lot of animations, I have found it to be fairly limited in having like very specific animations. So you may still have to create your own animations in the end, but it's a good way to get quickly started if you need to just animate something quickly. The final animation method here I will talk about is the motion capture method, in which we're using, in this case, the Vive trackers, which are a add-on to the HTC Vive. There you can see Miguel wearing the tracker setup we have created in our DIGI lab. You can see here in Blender the same model again. Here you can see the trackers when he's moving around in real 3D space, and it's being mirrored inside of this digital world. We have created a kind of setup procedure in which he joins his real position with a digital model, and then is able to control that model. It's not a perfect setup in this case, but it is viable. You can then record these animations and replay them. Yes, that was the last movie of our webinar. So at this point, there's just questions and answers left. Yes, I'll let the time go on.
Okay, so this was a quick overview of the work that we have done so far in DIGI-MODE projects, and of course we have the big weekly meetings, and we are looking for still possible for companies to join, to give us some ideas how they think these technologies can be implemented in their processes. As this is a public project, all the models that we will create, we will put them online so they can be used further on. If you have data that can be used for some of this visualization or some specific user case, that also is possible. So please, if you have some questions, post them in the chat or open your microphones. I think my colleagues will
Raise the hand,
just raise a hand and we will allow you to open your microphone and get some questions. And so obviously these three sectors, architecture and construction, the energy sector and manufacturing are closely related. And if you have a company that's doing something similar, that will be a straightforward job to implement something also with your models. But if we look also, of course, what our colleagues from MOVA are doing for the logistics sector, for the service sector, you can see even something that is not so straightforward looking can be added on. For expo centers, maybe I can go back to one of the slides in the beginning that we can discuss the content creation and the added value for these digital twins. Bear with me. That was that slide. So our plan is to have all these demos in all of the labs. So regardless of the fact if you are working for University of Vaasa, for BAMK, for Abo Academy, or for Novia, you can experience these environments for yourself. We have similar setup, similar hardware, and we will make the public models available. So if you want to try yourself, put on the glasses, grab the devices, the handheld controllers, and do some painting or go on the scissor lift. That would be perfectly possible to do in the place it's closest to you. Maybe some of the other panelists have something to add on. How do you see the work done so far? And some ideas for the next steps.
We can temporarily stop sharing here so we can see the. Yeah, you can continue talking.
Yeah. Can you still follow?
Yes, yes.
Okay. So maybe somebody from MOVA or Experience Lab can add.
Yeah, I can add. I think there's someone in the chat that has a question, but I just would like to add that.
Raised up.
I will try to pick this. It's this thing. I cannot share at the same time. I answer a question. I'm sorry. So yeah.
Yeah, I just want to add that one of the good benefits of digital twin is there's so many things that can be used for, and there's basically is the simulation part that really enables to test different things and just check how does it feel, and using the VR technology, how does it feel to be in that kind of potential scenario. So digital twins have been enabling by also from the hardware and software possibilities. So I guess that nowadays it's really a good tool or a good concept to actually companies have, or different industries, to come and test, and perhaps they might find interesting cases for themselves, for and new business opportunities might as well be benefit.
Yes, actually the barriers and the price of devices, hardware, software have dropped significantly. It's, as you saw, there are quite many tools now that you can make a straightforward workflow and get these tools not only for space station training or pilot training, but you can train operator in a small business. SME companies also can benefit from this value that the technology creates. So the entrance barrier have dropped significantly in the last years, and this is the major take from this webinar. If you don't remember anything else, just remember that you can test by yourself the tools in our labs and collaborate. And yeah, it's not gonna cost a lot to have a pair of glasses and a computer in your company and run it either for Expo or as a demo tool for your clients, for customizer, etc.
Yes. So now, yeah, if anyone has any questions, you can raise your hand. So, and we can allow, give you the ability to speak. Yes. Okay. Is there something?
I can add something. Joakim Majors here again from Experience Lab. I just want to say that when we were working on our case with the architectural case, and the way we did it is like actually having good contact with the company. So I mean, if you're a company and you're thinking about using digital twins in your services, it's really good to actually see to define the need, to find the problems. Where could a digital twin actually be a solution, or be of help, or be of added value to your process or to your company? So that's really good to actually be able to define what the digital twin could do or should do.
Indeed.
Yes. Thank you again, Joakim. Any other comments? Okay, still have 17 participants. I hope you enjoyed our first webinar. We will plan at least one or two more before the end of the project, which should be practically end of September. So some more implementation and discussion with companies for the rounds, and of course polishing the demos and the experience. That's what we are focusing in the coming spring and summer season. So thanks for joining us, and keep following us in LinkedIn, through the social media channels. Every organization have the project posted, so you can take a look also on the webpage of the project, where we constantly keep posting news updates.
I will put a link to the webpage in our chat here.
Yes, Joakim? So
No, we did this one.
yeah,
Okay, yes.
you can see the link to the web page in the chat also.
Yes.
Thanks again to all my colleagues, to all the participants, and I wish you a nice day. Stay safe, stay healthy.
Yes.
Thank you. Goodbye.
Bye.
Goodbye.
Goodbye, everyone.
Bye.
Thank you.